Greetings, M squared here. Today we're going to talk about a special exponential function called a compound interest formula. And this is used to find compound interest, which is used a lot in banking. So we're going to talk about what all of those different things mean, but first we're going to learn some new vocabulary. The word principal means the beginning amount. It would be the amount that you invested. Like let's say you're going to put $1,000 in a savings account. The $1,000 would be called the principal. You get interest on that money. So if you put your money in a savings account, you're loaning that money to the bank, and then they pay you a small fee to keep your money and to use your money. So they're actually using your money. A simple interest is just paid on the principal, just that initial money that you put in. But compound interest is paid on the interest too. So after a month, let's say they give me $5 for my money, then now I'm getting interest on the $1,005. And then the next month I'd get interest on whatever the new amount would be. And so your money would increase quicker because it's compound interest and not just simple interest. And depending on the interest rate and how long you put your money in, it can be quite significant. So there are different times, number of times a year that people compound your interest or figure out your interest. There's annually, which is once a year, semi-annually, which is twice a year. Change that because I put that wrong in your notes. Quarterly is 4 times a year, monthly 12 times a year. Bi-monthly, we're going to say it's 24 times a year, but some people can use bi-monthly for every other month too, but we're going to say it's 24. Weekly and daily. You can even do it continuously, but that's a new model that you learn when you get to Algebra 2. So we are going to talk about this formula. Now you'll notice that it's kind of similar to what we did before with our exponential model. We have an initial amount, that's our principal. We have what we're going to get out at the end. We have a 1. Remember, we had a 1 plus and a 1 minus. Notice this one's a plus because we're compounding interest. This one's always going to be a growth rate. Notice we have some new things, new people in town. N is the new guy in town. We had the R before, we had the T or the X before, but N is the new thing. And N stands for the number of times per year that the interest is compounded. Notice it's twice in the formula. Notice it's being divided by the rate here. That rate is as a decimal, and it's being multiplied by the time here, right? So we want to make sure we have all of those things. I won't make you memorize this formula, but I will ask you to use this formula to solve word problems. Just a little picture of what simple interest is versus what compound interest is. So if you were compounding interest quarterly, you put $10 in the bank and you had a 5% rate of growth. The simple interest would continue to grow 5% every year no matter what. This one is actually getting bigger because you're getting more money that you're getting interest on. So the more money you get, then the more money they're using to compound the interest. All right, let's do some stuff. Let's do some word problems. So keep that in mind. You definitely want to have that handy when you are using these formulas. So what will the value of a CD be at the end of 5 years? Now you might not know what a CD is. A CD is called a certificate of deposit, and it's a way to save money. So some banks offer different ways to save money other than a savings account. So you're going to give them $3,000. They're going to promise you 8% interest, and they're going to compound it quarterly. Right. So after 5 years, how much money will you have? Well, we've got an initial amount or principal of $3,000. We've got an interest rate of 8%, but we change that to a decimal. We know that it's quarterly, so that's going to be 4 times a year, and we know that our time is 5. So here is our beautiful formula. This is the initial amount. This is the 1 plus, notice the rate divided by N, the number 4, and then the 4 times 5 is the 20 that I get when I multiply the time and the compounds, the number of compounds 4. So here is my little formula. So I'm going to put that in my calculator. 3,000 times 1.02, because that is what I got when I divided 8 by 4, the number of compounds, and then it's to the 20th power. And what do I get? $4,557.84. That is after 5 years. So let's go. $4,457.84. Put a dollar sign in there because it's talking about money. What will the value of the CD be at the end of 20 years? So let's say you didn't take it out right? What would it be? Well, we're going to use the same thing, but I'm going to just show you that little formula to you. So we still have $3,000 that we started with. Our rate is still 0.08. Our number of compounds is still 4, but our time has changed to 20 years. So when I go to write my formula, I still have everything pretty much the same. That 1.02 is still the same because the number of compounds didn't change this. It's still compounding 4 times a year, but this is what changed. Now it's 4 times 20. My time is 20, and that's 4, the number of compounds. So 4 times 20 is 80. Well, the nice thing about this kind of calculator is you don't have to put it all in again. That's why I didn't press clear. All I do is backspace, and it takes me right there. And I can put an 80 right there because that's 4 times 20. And now let's see how much money is there. $14,626. So $14,626.32 because I'm going to round up because that was a 7. So you can see that it's quite a significant amount. I leave it in for an extra 15 years and I have $10,000 more dollars. So the more you invest, the better your chance of getting the more time you keep it in, obviously, the more money you're going to get. Let's try another example. It says, what would the value be after 20 years if the interest rate was only compounded semi-annually? Okay, so semi-annually is twice a year versus quarterly, which was 4 times a year. So now I'm going to change my formula, and I'm going to have to do the same formula, but it's going to be semi-annually. So I still start with $3,000. My rate is still 8%, but now I'm compounding twice a year, but I'm going to go for 20 years. So let's write that up. Y equals the 3,000 times 1 plus the rate divided by 2 to the 2 times 20. Well, 2 times 20 is 40, so that's going to be my 40. But what is 0.08 divided by 2? Now it's going to be 0.4. So we're going to compare, 0.04, sorry. We're going to compare it. So our little guy in there, instead of 1.02 like it was before, it's going to be 1.04. So I can go to that same one on my calculator and change that to 4. And then I'm going to change this to 40. We're going to see what the difference is. What if it was just compounded twice a year instead of 4 times a year? What difference would that make? So let's look. $14,403.06. I don't need that other decimal. So let's compare those two. Sometimes they ask you to compare and say, how much more would it be? Well, if you wanted to know how much more, you would subtract those two. Looks to me like it's about $223, right? That's the difference. Okay, now a different bank offers an interest rate of 7.5%. Now that's lower, right? But compounds the interest monthly. Well, that's more often. After 20 years, which account will have the most money? The 8% quarterly, the 0.75% monthly. So it looks like we're going to compare these two. All right, let's do it. So we still have our initial $3,000. Our interest rate has now changed though. So our interest rate is going to be 0.075. We are going to compound 12 times a year, and our time is going to be 20 years. So let's write our equation. Y, we're saying Y. I should be saying A because that's our new formula. Sorry about that. A equals the principal times 1 plus 0.075 divided by 12 to the 12 times 20 power. Okay, my n has to be divided by the rate here and multiplied by the time here. So let's put that in our calculators. First of all, I'm going to figure out what this is, and then I'm going to add it to 1. So 0.1 plus 0.075 divided by 12, that is going to be 1.00625. And 12 times 20 is going to be 240. I like to find those out first and then put them on my calculator because sometimes it messes me up if I don't. And you might find that too. But remember, we're always going to be logical when we get an answer. Make sure it makes sense. So times 3,000 times 1.00625 to the 240th power. That will be $13,382.45. So this was a 0.5% lower, but they compounded more often. What's the better deal? Well, that's what you have to write a few sentences about. So you would then write a few sentences about which one you think is a better deal, why, how much more that one is. I'm not going to do that for you because I want you to write that. But you'd talk about the difference between them. So you'd probably want to subtract and say, this one's this much more money. But that is how you do those problems. And then that's just some work that you have to do. That's your homework. I'll let you do that on your own. All right. Good luck with that. M Squared signing out.